set of coding. I can write a set of coding, and I can able to control the entire system with the help of a suitable processor. That's what I said class. I told you. I told you maybe in the semester you are learning microcontroller. It's one of the processor you are learning. Already people are speaking about i3, i5, i7, i11, and so on, right? So therefore, you people also have adequate amount of knowledge on processor, because whenever you buy any product, you are trying to look into the processor metrics, processor specification, processor storage, and other things we are trying to speak about that. And parallelly, you people have good knowledge in coding aspect or simulation or emulation. Otherwise, from certain coding like C or C++ or Python coding, and also these all the things. So whichever the coding part you are much familiar, get the processor code. You just code it according to your own application. But my point, every application, please remember in your mind, power electronics, you have an input. Then in the system part, you may have an inverter aspect or converter aspect. Converter in the sense we are trying to convert AC to DC, and inverter in the sense we are trying to convert DC to AC, vice versa. Leave it. Then again, I may have a processor. That processor, you design the processor. That processor will have an ability to drive the controlled action towards the particular machinery. This is what the things might be happening in the all industries. This is how the present scenarios happen on every industries when they are centralized towards the computerized system. Some 80s and 90s, all equipments, machinery handling, everything done by manually or done by people and other things. Now, in a centralized manner, or pressure control, valve control, or the water flow control, then temperature control, humidity control, then all moisture control, then the level of flow between the two media, everything are trying to be monitored in your PC, in your centralized unit with the help of a suitable processor. And many controls are trying to take part in either by directly or indirectly. So now, most of the industrial sectors, most of the companies, they are trying to be automated. So please remember in your mind, they are trying to use intelligent controllers. They are trying to use intelligent controllers. Please remember in your mind. That means a set of intelligent of coding or a program may be written. By that, you are trying to control it. Even yesterday's class also, I think I told you about that. Your washing machine, we can consider for a good example. Maybe everyone have an opportunity to see your washing machine at home, right? You have a motor inside, then you have a drum, you have a rubber part, and you have a processor board. So now the latest one is it will decide about how much quantum of the processor controller, or the processor will decide about how much quantum of cloth weight you are supposed to put. What is the standardization of the cloth weight? How much amount of quantum of cloth weight you have to put inside. Second one, you should know about using a suitable sensor. You are trying to close the door, and once the on-off control under category. Then water inlet and outlet sensed by the suitable controller. Then how much quantum of water are required during every stage of processor that we are coding. You are coding it in the processor. Accordingly, you are trying to program it. And the cloth material may differ. Then the timing may differ for every material. And the time duration required for spinning, drying, all everything differ. So it depends on the material. We can able to categorize the amount of time which is required for washing. All those things are programmed in such a way that we are trying to run the machine. So all these processes are coded. Along with that, the induction motor or which you kept inside, or a DC motor, so that maybe will help you to drive the mechanisms. So with the help of a suitable controller. So normally, due to short circuit or over voltage, mistakes might be happened on your processor board only, not rather than your motor or your drum or any other unit. There are many examples you may come across on a daily basis. You may come across with many applications on power electronics and drives. So please remember, Newman, it is also under one category on your men's technology. See, everywhere now people are discussing about sensors, right? I think last semester you might be learned about sensors and signal conditioning. So that means, please remember in your mind, today more amount of sensors are designed in such a way that so every sensor will have their own unique functions. Please remember. So here, this is just an example I just told you. Okay, there are n number of applications you may come across: electric vehicle, solar heater, solar unit, even your inverter which is installed in your house. These are all just an example which directly involved in the name of called switches. That means power electronics concepts are incorporated in these areas in the name of switches and the combination on the driving part on your machineries. So that's why I told you very clearly, when you start learning this paper, make your mind very clearly about you should have a clear brush upon the two things which you learned long back. One might be solid state switches, and another one might be your drives and actually. If you have that little knowledge on that area, the subject is nothing for you. The subject is very simple to you, and the subject is very easy for you being a sixth semester student. Nothing new we are learning, just an integration part and how this integrating type of things are working in the driving part. Maybe after completion of the syllabus, we may have a discussion about some uh, photovoltaic installation or electric vehicle technologies, and how government is trying to give subsidies on electric vehicle and the electric vehicle charging station. So today's scenario, people are everywhere. They are talking about all those things, right? Electric vehicle charging station, and some of you might be you purchased an electric vehicle, Ola electric vehicle or something else. So everywhere people are now discussing about the charging station, or how frequently or what is the miles and miles in between the miles you have a charging station. These are all the design constraints or design challenges as of now in Indian road condition. So in Indian road condition, these are all the metrics or challenges are now going on in the industrial sector. So these all things I think on a daily basis you may come across or you may aware about all those things. And solar plant installation at the home or inverter based UPS based system. These are all things maybe many of you have your own system at your house. Maybe you may have your solar MPPT, maximum power point tracking with the help of a solar panel. I think some of the houses you may have your own solar panel in the rooftop, right? So, but you do not know exactly what are all the components involved in that. Please you remember in your mind, components involved are like your solid state switches based inverter or converter and driving mechanisms. That means your solar panel will try to acquire the adequate or try to grasp the maximum amount of power of during the radiation time and try to generate it as a power with the help of a suitable inverter. So this is how the simple mechanisms. So even you yourself can able to install getting some subsidy amount from government, and you can install if you have in the rooftop, if you have space, if you have a real space in the rooftop of your house, you can also able to install to meet the power demand. Because today most of the cities are running with power shortage, right? Even in North India, some of the states, and in South India, even Chennai, sometimes they may struggle with power shortage and the huge power demand, and the industrial sector needs people's need, and during the hot time, more amount of air conditioners are required. Like that, huge amount of power demand as of now. Because one aspect, if you see, wind generation today we cannot get much power. Then another one, hydro during rainy time or during when the dam or reservoir or canal is fully filled. Okay, that time we can depend on hydro. Then tidal in India, that is not that much popular. Maybe in abroad it's there, Japan and other countries, but whereas in India it's not installed much properly, and they are not trying to get much amount of power. They are not trying to draw much amount of power. Then nuclear is there, but still we have a lot of other political issues, so we may have less number of plants, either in Kalpakkam or Kudankulam. These are all the plants which I am talking about in Tamil Nadu. Even in North India, some of the power plants are there, but that also people are quite afraid to stay nearby the area due to radiation and other things, all health metrics and health aspect. Okay. So like that, the more amount of people are here, more amount of utility, more amount of power demand, more amount of requirement on people, but at the same time, uh, generation of power is another question mark. Generation of power, we don't have adequate amount of generating power. That's why most of the EB bills are much costlier for every unit. People who are from Tamil Nadu, they know very well about it. Here, the EB bills are much costlier than North India. But many of the fellows are you are from North India people. You do not know exactly about the power tariff and other things. I think I'm sure about that. You may have less tariff than Tamil Nadu. Got it? Because Tamil Nadu, more amount of power is required in the, particularly in Chennai region. Chennai because more amount of industry, capital of Tamil Nadu, and also more amount of institutions like schools and colleges and other things. So therefore, when we have a more amount of demand on the power sector, then with that area only, these type of components are they are trying to involve with the other technology, like solar technology or fuel cell technology. These all technologies are came into existence. Thereby, people are trying to use a set of switches, solid state switches, either SCR, a silicon control rectifier, or another name thyristor, and other devices, diac, triac, diode, MOSFET, UJT, BJT. These all fundamental stories already you have learned. Anyhow, in the first chapter, again, we'll go through the glimpse of the important points. I'm not going to tell all the old stories again. At the same time, some glimpse of point which is essential to remember for us to move further in order to know about much better concepts. We will have a discussion. That's what I just wanted to tell you about it. See, one of the interesting paper. Maybe theoretical ways you may feel that quite dry, whatever I'm speaking right now, or whatever the slides which I'm going to project, you may feel that little dry. Again, we are learning solid state switches or motor, generator. What is this? We are not going to learn anything. We are just going to integrate, that's all. Please remember in your mind. At the same time, still these are all much essential in order to go ahead with the industries. That's why again we have a call for to learn. Please remember. So don't think that we are unnecessarily. No, you are learning many essential things. Tomorrow, some of the mechatronics engineers may be able to do some startups in the charging station. Because today everywhere people are talking about electric vehicle, solar heater, all many things are going on, right? Okay. Whenever any new startups are coming or new inventory things are happening in the society, please remember in your mind many big people like budding engineers like you are taking up an initiative or innovative ideas. All your innovative ideas will may be converted into action. Got it? So therefore, sometimes some of the mechatronics engineers, because you people are learning multidisciplinary, right? You are learning many things together, or you are trying to integrate many things on a single platform. Therefore, you people have an additional responsibility. Even if you get an opportunity when you go for installing charging station or electric vehicle implementations, these are all the areas you can focus on the future in future. So these are all the areas also you will have scope. Please remember in your mind. So learning this paper also will give you quite amount of idea and quite an amount of requirement in the society. Society needs it will give. Please remember. So therefore, what I'm trying to tell you is, whatever the subjects you are learning, first you should know about that, why we are learning that paper. While after learning, what sort of outcome I will have. Whether this subject will be useful for me to do some module in the society in future or doing my studies, or what sort of applications in the society. These type of papers have more amount of applications in the society as of now. And today's current scenario, everywhere people are speaking of. You all know about that, right? Some years back, people are talking about all digital India, data storage. Now, okay, everybody tired. Okay, everyone knows about that. What sort of data is required? How do you send the data? How do you receive the data? How do you retrieve the data? Data science and other things. Data science, let's just storing the information, storing many histories, past records, and other things. Okay, fine. At the same time, now other trend. Okay, every inventions comes when there is a new trend. Okay, now people are again speaking about what I say. People are speaking about electric vehicle, electric car, and other things. Everyone started speaking, right? Electric two wheelers, something like that. People are trying to speak due to the demand and due to the customer needs and due to the more populated countries like India and China. Oh, okay. So therefore, we also should convert our mind, or we also should convert or transform our mind towards this type of latest field. Thereby, we are supposed to equip ourselves and explore our ideas into action, and we can also able to start up some new things or new product or some new startups. That is the basic idea. I just wanted to tell you. Okay, so this is how the scope of this paper. Please remember me on that. Maybe while learning theoretically, you may feel little dry. But when you go for a practical implementation, these are the areas where you will have more scope in the future. What my point? Okay. Even some of you might be speaking about among yourself. You might be speaking about electric vehicle, electric car, whether it will be okay, how much time I can able to store my charge, and how much time is required for me to move further. and what sort of charging stations are required. All those things we are trying to discuss, right? So therefore, what I'm trying to tell you is, please remember me in mind. We should have little knowledge on the inverter side as well as converter side. Same thing only, again, whatever you are learning, again you will have a repetition in the seventh semester called industrial electronics. How these are all the devices are used in industrial perspectives. Now, whatever we are learning here is a driving mechanism. At the same time, in the later part, we are trying to discuss about the industrial needs and the industrial perspectives. So now I think you have got some overall idea about this subject. Otherwise, no, you may ultimately you may lose your interest. Lose your interest, and you will not do much things on the forthcoming days. That's why, in order to give a overall view and a overall idea about the content and the paradigms behind the subject I just told you. Still, many more things I can speak. Lot of practical things are now current researches are going on. Power quality, power metrics, power signal conditioning, on smart grid. Now people are speaking about all smart grid, right? People, earlier people are speaking about smart sensors, smart devices, smart phones, smart TV, smart many smart. Everywhere people are speaking about all smart, right? There is a word called smart, but what exactly smart became that? All the role of mechatronics engineers with the help of that, all tiny integrated components are together and converted as a chip or processor, and thereby doing many actions. So therefore, in the future, please remember in your mind, most of the applications, most of the requirements, everything are based on this type of area. So being a mechatronics engineers, please have a clear understanding why people are speaking about all smart manufacturing, smart additive devices, smart systems, smart conversions is all people are speaking about as of now. So please remember in your mind, smart technologies will have a vital role on the forthcoming days. So please pay much attention when you go for any product development or any product implementation. Even being a robotic specialized people, you may require a certain amount of motors for the functioning on your robotics, provided some DC motors you are using, right? So that DC motor you can drive with the help of these controllers or these power electronics switches. So for you also is required when you go for your own modeling on your robotics and other programming aspect. So everywhere this you will have the application for on this type of subjects. Got it? Now I'll just open the slide for you. So these are the introductory part from my side, and maybe some more examples. I told you one example like washing machine. I told you even your electric heaters at your home. Electric heaters you may have. It works on the principle of Faraday's law on electromagnetic induction. So E equal to minus d pi by dt. See these many things known by you through either in the form of physics or in the form of your engineering basics you might be learned, but we do not know exactly where we are using, and we may come across many applications, but we do not know what sort of concept behind that we may not have. That is the drawback we have. Whatever the equipments, machineries, or all those things which I mentioned here, everything 90% may be available at your home or nearby your area, or you may come across on a daily basis. But we do not know what sort of principle or what sort of concept or what sort of terminologies or what sort of components behind that we never bother about that. This is how the things may be happening. Please remember in your mind. Even in your house, you may have your UPS, right? Inverter-based UPS, uninterrupted power supply unit. How many of you got an opportunity to, whenever your inverter failures or your battery failures due to the shortage on distilled water and other things, how many of you have an habit of checking your battery as well as your inverter? Being a sixth semester student, almost you are an engineer right now. I can call you the third year students as now engineer only, because up to second years I may treat them as students, but third year and fourth year I may call them as engineer, because now you have an ability to interact with any people or communicate with any people or design any product or convert the product into action. That abilities now you have got. You are in the sixth semester, almost an engineer you are. So, did you have get any ever get any chance to do all those small sort of works at your home, or did you have any practice something like that, or do you have any other industrial backup at your home, or in your parent side, or in your relative side, or do you have any tie-up with any industries and you come across with internship or industrial training? Do you come across in that? So if not, in future you try to equip your mind in such a way that you focus towards on many practical things rather than keep on sticking on to the theoretical. See, theoretically many things we can speak, but while start implementing practically we have to consider into many constraints. But at the same time, remember in your mind, while starting implementing on practical aspects, some of the failure metrics also we have to face. But that failure things will give you adequate amount of knowledge and confidence towards for a better moving or towards for better target. Please remember me. Every time my hardware product may work or may not work or may attain good result or may not attain good result. That is not a matter. At the same time, when I go going for my own startup or my own firm, or I may become an entrepreneur, at time lot of challenges I have. That's why I told you 4 or 5 people join together, share your ideas and convert towards action. This is how more amount of products or more amount of inventions, more amount of prototypes have been developed in the society. Otherwise, nothing would have happened in the society. Got it? So this subject, all the 5 chapters, whichever is required, I told you on yesterday's class. Okay, now I'll just open the slide. Okay, so the first part of the PPT. Part of the PPT I just opened. Okay, so electronics and drives, you all know about the code. Okay, these are all the total 5 chapters you may have. See, so far, listen, last class and up to this 1 o'clock, almost 1 o'clock another time. Really, many outlined areas I gave to you people. Any doubts in this? Guys, those were attending the class from last class and I think yesterday's class and today's class. From the outline, do you have any idea or do you want to interpret some more points from your side? Because some of you might be an implementer people, some of you might be implemented many things or many circuits or many modules. So do you want to interpret your own ideas here? Also, you can also most welcome to share your ideas so that I can also gain some more knowledge from you people, and also I can also able to convert that type of information to the other people. Like that, only a collective amount of learning towards from both the end. Got it? Otherwise, no. From one end, if I start speaking, and other end, if you don't doesn't respond, there's no use about that. So always from both the sides, when we start discussing many things, at least we can gain our knowledge. We can trigger ourselves, and we can focus on much knowledge about that. Got it? So any other point you wanted to add? Because some of you might have good points than what I shared here, and some of the points I may forgot to discuss with you people. So that and all maybe in the later part when I get the moment I get the ideas, at that time I'll share it with you. So now any points or you wanted to add with that along with my introductory talk on this power electronics and drives, anything you wanted to add? Because you also have more knowledge. That's what I told you very clearly. Every individual who are present here or in the third year, you have adequate amount of knowledge on this paper. That's why I told you this subject is easy to you. Getting mark, scoring mark, all those things, forget about that. What sort of new things we are going to learn this time, and in what way we are going to apply? Is it possible? At the end of the semester, my question towards you people is, will you have an ability to do something in your house or to implement some prototype model at your house to generate your power? That is what the task I'm going to give it to you. Others, forget about we are not going to develop a motor or a generator, nothing. My simple question is that there are a lot of n number of latest applications are going on in the society. Move towards that. Go to the YouTube, download it, just watch that. Then bring that idea. We'll have a discussion, open forum, and we'll have a discussion. What sort of abilities or what sort of knowledge you are trying to gain over these sessions will make a conversion towards you people to do some product. That is much essential. End of the semester, I want every individual or every set of people who wanted to do some kind of product or a product or prototype at your home or at the place where you are trying to reside or at the place where you are doing, or go to some industry and have a tie-up and share your ideas, and if possible try to convert it towards an action. That is what the end of the outcome I just wanted to from your people. Not simply sitting here in between writing some tests, getting mark and 95 S grade or O grade, whatever you may call it as. That doesn't work out in your life. Being an engineer, when you leave from the college, at least you should have little amount of ability to know little fundamentals and little knowledge on implementation. That is essential for an engineer. Please remember in your mind. So that is the question right now I put forward to you people. The end of the semester, I am also just expecting you from you people. Got it? Okay. So unit one, semiconductor devices, unit two, control rectifiers and choppers, inverters and AC. Whenever rectifiers, obviously what you will be having? You will have inverters. Then DC drives and AC drives. What people are speaking about DC drives, or DC motor generator, DC generator, and so on. All old stories like Fleming's left-hand rule, right-hand rule. All those things you have learned about that, right? How the magnetic lines will have a mapping over that, the magnetic lines path and the alignment of the movement. All those things you have learned. And here I am trying to speak about AC drives, where we are trying to speak about induction motor, and then three-phase induction motor, synchronous machines, then permanent magnet synchronous motor. These all special machines we are trying to speak about in terms of a AC drives. That is what the message I just wanted to give it to you people. So this is how the outline of your curriculum. Okay, so again, Paul Tonics. So now, as per the regular requirement of your syllabus and as per the requirement on the way which the syllabus is formulated, accordingly, hereafter we go ahead. Once the syllabus completion, everything over, some more general topics. I told you just now, right? I told you many general topics. If the time permits, definitely I think we'll get time since it's been online. So we will discuss about many practical things which are going in the society, like electric vehicle, charging station, then solar implementation, solar panel formation, then how to design the solar panels and arrays, and how do you design which inverter is suitable for to drive more amount of power. These all things maybe we will have a later part of discussion, so that at least some I will find out some people from your class will try to implement something in the time permits. Maybe I think I'm expecting you people as early as possible for the physical. If you come to physical mode, to be quite well and good. But anyhow, even in online, we can have a discussion. Even now, people who are good in some sort of doing simulation and other things, please go to open source and get PSpice software. This is called software called PSpice. P Spice, SPIC, PSpice software or MATLAB software. I think you all have MATLAB software, right? And there you have a toolbox called the power electronics. Go to that, take the utilize the toolbox and draw some circuit, whichever is available in your textbook or from the net. You take some circuit and connect the motor and see what is the characteristics, what sort of changes happened on your torque, speed, and voltage and current. How the rise time, delay time, settling time, and peak time will have a change on your during your steady state and your transient state. These all things by practically you just see that through simulation, so that also you will get much more idea before you go for practical implementation. Got it? So that's what I tend to do. So either you get a software, PSpice, or if you have MATLAB, it's well and good. There is a toolbox. There are various toolbox you will have, right? So in the toolbox side, you just go that. There you may have power electronics toolbox. That power electronics toolbox, if you go that, all components you will get. Input side, output side, the voltage, current, the thyristor, ACR, diac, triac, or the inverter side or the converter side of the things. Then the driving part on the required device on motor or induction motor or synchronous machines and BLDC, brushless DC motor. These all things are available. Take it and drag it, drag the picture and keep it on the screen. And there, when you try to connect all those things and then see the output, how the changes are happened on your various parameters or various characteristics. That's what I just wanted to tell you about. Okay, because I think many the things we have discussed. Suppose if I go on speak like this, then we may not jump into the syllabus. We may go many things which is happening in the society and which is happening on practical as of now. That we will discuss it later. So power electronics deals with the use of solid state electronics, the control and conversion of electric power. Please remember in your mind, you are trying to control, at the same time you are trying to convert electric power. Then applications of power electronics include rolling mills or paper and textile mills, traction vehicle, crane, machinery tools, control, battery charging units, These are all the places. This is very limited. Okay, these are all the selective areas here we have focused. I told you many things, so you can also recollect all those things. Even some more applications I may forgot to tell you. You may remember. So please add on to that. Rolling mills, paper, textile mills, traction area. This power electronics plays a vital role. Then crane, machine tool control, battery charging, etc. Everywhere this power electronics are solid switches plays a vital role. Power electronics is connected with power engineering and electronics engineering. As you are aware, power engineering deals with generation, transmission, distribution, utilization of power, or power with high efficiency. Then equipments associated with electromagnetic principle. Yesterday's class I told you about electromagnetic principle. When the EMF is induced in a circuit is directly proportional to the rate of decrease on the flux. E equal to minus d pi by dt, or E equal to minus m di by dt, depends on the self-inductance value or the mutual inductance value. The moment you start giving a supply, your coil gets energized. Based on the energized, what will happen? A flux is being generated. The flux will have an alignment with the same coil. Then you call it as a linking flux. That linking flux will give an effect called self-inductance. The same amount of flux which will have a linking with the secondary coil, then you may talk about mutual inductance. Provided mutual inductance may happen, depends on the polarity on the current direction. Please remember. And electronics engineering deals with distortionless production, transmission, and reception without much consideration to efficiency, or acute associated engineering with the physical phenomena in the form of vacuum, gases, vapors. These are all the earlier days. Vacuum tubes, we may call it as vacuum tube. Um, Even your thyristor might be called it as valve. Earlier days, people might be calling it as your thyristor might be calling it as a valve and other things. Please remember in your mind. Okay. And advantages: high efficiency due to low loss, fast response, long life and reduced maintenance, high reliability, small size and low weight. That small size and low weight obviously will have an ability to transport, or to transport from one area to another, or to move from one place to another. These all things are possible. So these are all the basic advantages. Disadvantages: introducing harmonics. Harmonics interfere with the communication system. Please remember these two advantages. At least disadvantages you should remember. Whenever we go for the switching devices, please remember in your mind, or electrical components which is integrated with the machinery unit, please remember in your mind, whenever we are using switches, it may have tend to produce more amount of power. See, in the laboratories, you may have saw many waveforms, like some kind of ripples, a kind of distortion, a kind of disturbances may be happened on your original signal. You may have an input signal, but when you have checked the output value, sometimes a quite amount of harmonies are present when you speak about electrical things. You speak about electronics, you may speak about distortion, you may speak about the other name, one more name is called, I forgot the name, distortion, uh, vibration. These are all the things we may able to see about a kind of flickering in the waveforms, or a distorted waveforms. These are all a kind of things may be happen in the name of harmonics. In AC, we might be calling it as harmonics, but in DC, we might be calling it as a distortion. So this harmonics sometimes interface with the communication system. What exactly we are trying to speak about communication system? A communicative device which are trying to send or retrieve or receive the data. That all communicative media from sender end to receiver end. It all will have a direct impact over this harmonics. Even please remember in your mind, now I'm speaking to you people, right? I'm speaking to you people. See, I'm in Chennai. You people are some of you in Chennai, some of you are in northern India or Kashmir or whatever may be. Some of them may be from Kanyakumari. Okay, whatever may be. One in the north end, another one in the south end, and I'll be in the middle part, not middle part, but Chennai. Okay. Therefore, my voice may be audible for some students. Sometimes my voice may not be audible for many students due to a kind of disturbance, because my speech signal is an analog in nature. So my speech signal analog in nature, they will have a conversion to digital. That one will be transformed. Analog to digital conversion will be transformed. Again, from your end, that digital will be converted as a analog one. That analog you can able to see through your speaker or your headphone or whatever the other accessories you may have. So while this type of transmission, voice transmission happening, either an audio transmission, please remember in your mind, miles and miles together, due to a kind of interference or due to a kind of communicative failures or due to a kind of harmonies, sometimes my voice may not be audible, my voice may be with a lot of noise and other disturbances, some sort of sounds may be coming, and these are all the quiet disturbances happen, and all these disturbances may be happen during the time of rainy and other times, or due to power fluctuation. Sometimes in my side, I may have huge amount of power fluctuation that also will reflect and affect the quality of my signal. What my point? It may affect the quality of my voice signal, and sometimes it may create a lot of disturbance to people to from the receiver side. What my point? So these are all the challenges we have in the engineers. Whenever any product design, any product development, we are simply speaking about all product metrics and other things, but a lot of challenges are directly and indirectly involved. Please remember that. So this is how the harmonics interference with the communication systems. Okay, these are all the power electronics converter types. You all know about that diode rectifier or a single phase controlled or three phase controlled rectifier stoppers, fixed AC to variable DC. Then inverters, just vice versa. Rectifiers AC to DC and inverter DC to AC. Then AC voltage controllers. So AC voltage controllers in the sense we are trying to speak about uninterrupted power supplies, switch mode power supply. SMPS, you might be heard about that, right? Yes, SMPS, switch mode power supply, might be used in your power supply unit. Then voltage controllers, voltage regulators, you might be learned. So voltage regulators, so SMPS, switch mode power supply. Maybe I think some of you might be having your desktop system at your home. I think how many of you have the desktop system, some earlier version? If you have, if you just open the cabinet on your, I say, if you just open the cabinet, uh, you can able to see the SMPS unit separately. Even you yourself can able to replace the SMPS and you can put the new SMPS. So SMPS switch mode power supply will give an adequate amount of mode of switching. So due to the instant of mode of switching, it may give the required amount of power to the particular unit. So you may have your own switch mode power supply or for a small unit you may have. So AC voltage controllers, these all things comes under voltage controllers and the cycloconverters. So cycloconverters might be mostly used in the aerospace applications. Many of the aerospace applications, they are trying to go ahead with the cycloconverters and everything. Not only cycloconverters, please remember in your mind, there are impedance converters, then buck converter, boost converter, then combination of buck and boost converter, then Leo converter, super lift converters, then one more type, I forgot the name, buck boost converters, then cyclo, then peptides, or that means a set of impedance values. So two set of impedance values are connected in the pi network and they are trying to use it. But all together, if you see that, I am talking about many converter types, right? But remember, if you look into very clearly and keen on the picture on the every converters, only a minor changes are there in the bridge network of every component. Please remember in your mind. We don't have more amount of change. That's why I told you all converters are ready-made converters are available in Google. You can get the entire simulation diagram and you can run it on your MATLAB, and so that you can get some more practical knowledge on that. Please remember in your mind. So very minimal minor component changes only you will have whenever you go for any type of converters. Got it? Okay. And sometimes the converter type may vary, depends on the application. Sometimes my applications may be a little heavy applications or heavy machinery unit. Then my converter type converter requires a high amount of switching frequency. I think yesterday's class I told you about switching frequency. F naught equal to 1 by 2 pi root of LC. Okay, so if my L and C value will increase, automatically what will happen? My switching frequency get increased. So F naught equal to 1 by 2 pi root LC. L, I speak about inductance, and C, I am talking about capacitance. Please don't forget. Okay, this may be the general diagram of a power electronic system. We are now to stick on to power electronic system, and so on, right? So, power electronic system, please remember in your mind. Okay, I'll just show the diagram. So please remember, this is the generic representation. Any system for a beginner to understand the exact pedagogy. Please remember in your mind, we also should describe every system with the help of a block diagram. Am I right? So therefore, this power electronic system diagram will give you a clear idea what exactly happened in your power electronic system. So I have a control circuit, I have a converter or inverter, then I will have a, definitely I have a load. Load in the sense I can call it as another drive also, another machine, another motor, something I can connect it to the load. Or the output side, I may load, I can call it as various name. I can call it as output side, I can call load, or I can call it as a machinery, or I can call it as motor side, or I can call it as output side. These are all the various names I can call it as. That means I have an input signal, my control circuit will have an ability to control the important aspect on the signal or taking a signal and trying to give a better signal to drive the converter either in the form of a AC or in the form of a DC to drive the load. What exactly feedback does here? Feedback will take a part of the output, feedback to the input side for error correction. That means I can connect one more term here, comparator. Right? I can connect one more term here before the control circuit, call it as comparator. I think this type of diagrams you might be learned in your system dynamics, right? 1 year back you have learned system dynamics. So you might be learned about system dynamics. There you may had a lot of discussions on this type of things. What exactly feedback and how do you control? What is comparator? What is controller? These all things. Maybe you had earlier discussions. Okay. So this is how the power electronic system is described. Now unit one semiconductor devices. Okay, now all the old stories, maybe you all remember about all the these old stories. I think now you will remember many things. So for whatever I spoke, you may thought that this is something different, something new, something very vague and other things. No, nothing vague. Actually, interesting one, quite interesting one, and quite applicable to implement. And I expect every individual to do some sort of implementation in the end of this semester. If time permits, if you come to the college, we will also have a much discussion on the charging stations and other things, or we may discuss about the electric vehicle. Okay, so please remember me on that. Okay, now unit one exactly we are trying to enter into that. I told you about switches. So unit one entirely we speaks about the switches. What are all the switches we have? Power diode, transistor, MOSFET, IGBT. What is MOSFET? Metal oxide semiconductor. Field effect transistor. What is IGBT? Integrated bipolar transistor. Gate turn on thyristor. Triode AC switch. Then silicon control rectifier. Then static induction resistor SIT. So these are all things you might have learned about various switches. So various switches, you may have a basic structure of a unit. You may have a triggering methods, either a turn on and a turn off time, and various amount of commutation to technique to give the adequate amount of voltage, forced commutation and natural commutation. Then what sort of firing circuits are required for ACR? Firing circuits are required in order to have a smooth conduction angle from one half of the period to the another one, like duty ratio equal to T on divided by T on plus Tf. That means the entire half cycle, where from which angle you are trying to trigger or you are trying to give a kind of firing to SCR to give an adequate amount of triggering pulse to your SCR gate wall and to conduct. Got my point? So anode terminal, cathode terminal, gate terminal, these all things you will have. Okay. So power semiconductor devices and their classification. So power diode, power transistor, power BJT, bipolar junction transistor, MOSFET, IGBT. Then thyristor comes under the category of SCR, triac, GTO, gate to turn on. Okay. Okay, these are all the diagram. See, these are all the areas. Okay, I'm not spending much time because it's known by you people. Already you learned and you all know about the symbolic structure and other things. Okay, so even I told you some first two, three units are fully known by you. Maybe the fifth unit when you come, okay, we'll have many interesting things to discuss. That time we'll spend much more time. Okay. So here the diode structure, anode and cathode, A indicates anode and K indicates cathode, BJT. You all know about that emitter-based collector, and already it's looked like a transistor. This transistor might be acting as an amplifier. You all know about that. Okay. Transistor, you may have PNP type and NPN type, and back-to-back transistor connected pair may be called it as Darlington pair. These all things known by you. I just wanted to brush and just triggering your mind towards this type of learning. Then SCR. SCR, here you have anode, cathode, and the gate to terminal, or there only you are trying to give a triggering sequence of pulses. Okay, these are all the commercial pictorial representation. If we go to the shop to get the component and patch it on the particular network or in your product development, you can have the materials like this. Okay, forward bias and reverse bias. So please remember. So the first one you have anode and the cathode. Then the second one forward bias. Okay. So positive polarity with respect to anode, with respect to what I say cathode. So here you have a load. You have a which load is connected? You have a lamp load or an induction load. So either we may call it as a lamp load. So output side I may have a lamp load. So the first part of my diagram where I have changed my polarity. My polarity positive, my anode is connected positive with respect to cathode. Thereby forward bias exists and thereby lamp gets on. Second case, what will happen? My anode is connected to a negative potential with respect to cathode. Thereby my device will be in operation. So forward condition and the reverse condition, or the positive half cycle and the negative half cycle. Then BJT commercial. This one is for the practical. If you go to shop, you may, or if you go to some electronic shop, you may get a component bipolar junction transistor or power BJT. Various models are available with heat sink and other things might be provided. Various shapes and other, the power ratings might be different. Okay, whenever you get something with these components, see, whenever we go for electronic or electric components, we may tell some specification, right? That is called it as power rating, the rating of the particular device. Please remember in your mind. Okay, and this one is for by seeing the diagram, you all know about that NPN and PNP, or it may be like it call it as a BJT. So how the forward bias happens and how the reverse bias happens. So this may be the diagrammatic representation of your base, emitter, and collector. Same structure, please remember in your mind. In many aspects, many amplifier, when you will learn in the third semester, Class A amplifier, Class B amplifier, then Class C amplifier, then Class AB amplifier or push-pull amplifier. These all amplifiers when you wanted to amplify the signal. You have used this that type of transistors. In the name of transistor or in the name of a BJT, you might be this appearance looks like a transistor based model, and there you might be learned about all those things, power devices. So please remember your mind. So here B indicates forward biased and C is reverse biased, and C indicates collector and B indicates base and E indicates that one is PNP and another one is NPN. Okay, this is maybe the typical diagram, diagrams, the commercial point of view. If you go to shop, this is how the pictorial representation or the structural representation on the words. Okay, next one is SCR. SCR, you all know about that. The other name might be call it as thyristor or silicon controlled rectifier, anode, cathode, gate, terminal. Controlled turn and uncontrolled turn off, then pulse ticket. You are trying to give sequence of pulses onto the gate signal. Thereby, you are trying to trigger your device to on in such a way that with certain interval, you are trying to drive the device. That's why the amount of pulses are required. What sort of pulses you have learned in the earlier classes? You might be learned about pulse width modulation, asymmetrical pulse width modulation, sinusoidal pulse width modulation. Am I right or wrong? See, these all things known by you people. That's why I am also telling in a fast manner, because these all fundamentals are known by you. That's why the prerequisite of the subject is solid state and drives and actuator. Learned earlier, the semester already gone. So now I'm just giving the overall idea to you. So there are a number of pulses or gate pulses or methods are there. So switching mode pulses method is asymmetrical pulse width modulation, generic pulse width modulation, then synchronous pulse width modulation, then pulse width modulation with the with certain conduction angle. So these are all the things are considered here for giving a triggering pulses. Various amount of pulse width techniques are available. Now these devices are based on turn on and turn off characteristics, uncontrolled devices and controlled. So all the devices either you will have a turn on characteristics or turn off characteristics, or through turn on and turn off by manually you are trying to turn on and turn off the devices. Please remember your mind. But at the same time, gate signal, you are trying to give a kind of signal to the particular gate, thereby you make the device to on, a continuous one or a pulse tone. Maybe for BJT, you may give a continuous signal. For SCR, you are trying to, just now we discussed about pulse, right? Asymptotical pulse width modulation or pulse width modulation, synchronous pulse width modulation. You are just triggering the sequence of signal in the form of a pulses. Please remember me. Form of a pulses. So then voltage and current bipolar and unipolar. So BJT is a bipolar junction device, a bipolar junction transistor. Unipolar silicon control rectifier is a unipolar. So voltage and in terms of voltage and current. So three things we are trying to consider: turn on and turn off. Then gate signal requirement, which is trying to trigger on the particular device, either in the form of a continuous one or a pulsed one. Then the next one is voltage and current capability. Okay, this is the again the device structures, diode structure. We saw that BJT and SCR. Same diagrams already we saw. Now basic structure and operation. This is the power diode. Okay, the power diode structure, anode, cathode, and between the two metals you have a ceramic insulator. So in the anode, in the diode, you have a in both the sides you have a metal. Between the metal, what you have? You have a insulator. So the forbidden gap between the valence band and conduction band are high. It requires large amount of energy to transmit from one band to another. So that we might be call it as the energy band or energy gap between the conduction band and valence band. Okay, this may be the structural features of power diode and its symbol. So this is the power diode symbol. Anode, between the anode and the cathode, you may have a subtractor. So again, P and N combination. Anode and cathode. A indicates anode and K indicates cathode. Okay. What are the structural features of power diode? Okay, maybe if you to speak about power diode, I think these all the things earlier you learned about that in your physics as well as in your solid state structures. It consists of heavy doped 10 power 19 coulombs per meter cube or N plus substrate, or the lightly doped area is a N layer in epitaxial growth. Then N layer is the basic structural feature not found in the signal diodes. So please remember in your mind, in the signal diode, we are not considering the N layer. And the greater the breakdown voltage, more the N layer thickness. If you wanted to have the more amount of breakdown voltage, then more is the N layer on the thickness side. So this is the structural features of your power. Okay, this may be the characteristics I told you about the voltage and current characteristics of a signal diode. Every diode, not only diode, even your BJT or your SCR, you will have a characteristics, the forward characteristics and the reverse characteristics, where exactly your cut down voltage gap, where exactly, I think this one you have done it in your laboratory, maybe the same graph you have drawn it in the lab. You have a forward characteristics at the place where you have a cut-in voltage at the range of approximately 0.7 volt, 0.7 volt. There you have a cut-in voltage. Then you will have a reverse characteristics. Okay, and here the reverse recovery. So here the diode reverse recovery on the first one. The first one in terms of a current. That means 1/4 of the value might be considered in terms of the reverse recovery area, and the second one, the power losses might be considered. The power losses might be considered. Please remember in your mind due to the combination on both the voltage and current. The first case you have a current due to the reverse recovery on current 1/4 of the value. The second one is you have a minimal deviation in terms of a voltage, and RR indicates reverse recovery time. RR indicates what? Reverse recovery time. And please remember, when you consider, when you combine these two cases, please remember you have a quantum amount of power loss in the diode that might be due to on state and the off state in terms of a time period you will be getting. Why either one case in terms of a current, another one in the case of a voltage. So variation of forward current and forward voltage drop the final one which will give you the power loss in the diode, either in the form of I square R or another one in the form of V square by R. These two equations as I discussed earlier. Okay, so reverse recovery time, here it's mentioned, if the diode is forward bias, it conducts and it is to be turned off. Takes some time to extinguish, or it may take some time to allow the free carriers to flow across the junction. Then this required amount of time, this much quantum of time which is required for an electron to get back to the original region or the n regions and the holes, then it is called it as reverse recovery time, RR time, small r, or suffix R time. Then the second one, charge flowing during reverse recovery time, is called as reverse recovery charge. So how much quantum of charge are required during the reverse recovery time? So that's what I told you. Here, time and frequency are considered. So during this time, the total current flowing across the diode is negative because carriers flows in opposite direction with respect to forward bias. TRR is the reverse recovery time measured at the time between the zero crossing of the diode and at the current at the peak time. That's what we learned about 1/4 of the value. 1/4 is nothing but what? 0.25. That means when you convert it into percentage, what will happen? 25% of the peak reverse current. Please try to understand. So here they are trying to give about 25%. 25% in the sense what? The graph we saw about that, right? 1/4 of the value. 1/4 is 0.25. So 0.25 when you convert it in terms of percentage, 25% of the peak recovery time. So TB is the time between maximum reverse current and the 25% of the maximum reverse current. IR is the maximum reverse current. Final point, please remember, the charge stored in the bulk semiconductor materials are considered into account in order to maintain the TB value, or the value, the time between the maximum reverse current is based on the charge stored in the semiconductor. The charge storing, in the sense we are trying to speak about the two components L and C. Please remember here. Next one, the reverse recovery time is measured from the initial zero crossing of the forward diode current when the current reaches 25% of the value. That means from the origin, from the baseline, it is crossing the zero crossing of the forward diode in order to reach the value of the 25% of the maximum current value. Maybe these values might be depends on, one may be due to temperature, another one due to the rate of change of current value, another one due to the commutation happened due to in terms of a forward current. Please remember in your mind, these the points are very, very important. Reverse recovery time we noted. That means the value might be 1/4 of the value or 25% or 0.25. Okay, fine. Now, these all values depends on either junction temperature or rate of fall of forward current or due to commutation. What are the commutation we are using? Either a natural commutation or a forced commutation. Natural commutation, the commutation by itself it will take, but forced commutation, what will happen? You are trying to give an instant of triggering to the gate terminal, thereby you make the devices to on for a particular conduction. Please remember the name. Now you have to equation. One equation, reverse recovery time equation, is a TA plus TB, or IRR equal to TA into di by dt. Di by dt is nothing but the rate of current, the rate of moment of current in terms of di by dt. So TB by TA may be called as softness factor. So here another one equation is the total amount of charge, the total amount of charge which is considered during the amount of reverse recovery time during the blocking condition. So 1/2 into IRR into TA plus 1/2 IRR into TB equal to 1/2 IRR into TRR. TRR is nothing but the combination of TA and TB. Please remember in your mind. So from this equation, we will be getting the cumulative value 2 into QRR divided by TRR. RR indicates reverse recovery time. Okay. Next one, reverse recovery charge. Okay. One is a TA and another one is TRR. So, okay, 2QRR divided by DA by, from the same equation. Okay. So now we are trying to negligible, certain amount may be negligible or TB amount may be omitted. So therefore TRR is approximately equal to TA, or TRR is in general root of 2QRR divided by di by dt. QRR is nothing but the total amount of charge which occurs during the reverse recovery time, and the di by dt is rate of change, amount of change of current. Then IRR is nothing but reverse recovery current. Sorry. Okay. Now, okay. The final equation, okay, one is reverse recovery time, another one is reverse recovery current, and the third one is uh, the total charge which is enclosed by a particular path in terms of reverse recovery. So these three equations, at least you should remember. One is QRR. There is nothing but 1 by 2 IRR into TA. Again, 1 by 2 IRR into TB. And both the combinations will be added together. We call it as TRR. TA combination on the forward conduction, TB on the reverse conduction. All together, you are getting the value 1/4 of the value, or 25%. That values together, you may call it as reverse recovery time, TRR. Please remember. Second equation you should remember about TRR is nothing but root of 2QRR by di by dt. Rate of change of current. Divide, that terms comes in the divided part, and in the numerator side you have a total charge which accumulated, or the total charge which accumulated on the reverse recovery time. And final one is reverse recovery current. So these three equations, please at least remember in your mind. So the power diodes may be classified into three categories. One may be standard or general purpose diode. Second one, fast recovery diode. And the third one, Schottky diode. I think Schottky diode also you might be learned in your solid state switches. But Schottky diode normally very few practical purpose we may go with. That's why I think you may not learn more things about Schottky. Okay, so this slide, one is diodes might be considered as general purpose diode. Second one, due to fast recovery time, fast recovery diodes, reverse recovery time may be less than 5 microsecond. And the Schottky diode, you will not have recovery charge much, therefore you will not have no minority carriers. And the fast recovery diode may be used in DC to DC and DC to AC converter. Because second one is very, very important. Fast recovery diode might be used in DC to DC. DC to DC in the sense what? You are trying to convert, it is almost like a chopper. Fixed DC to variable DC we are learning, right? So that means fast recovery diodes are meant for sometimes as choppers. Similarly for the other type of converters like a DC to AC converter, converter types. That's why I told you conversion and the inversion principles are applicable based on the requirement. Either I can consider as a converter or I can consider it as an inverter, provided if I know how to transform from one to another, either from a conversion on AC to DC or from the conversion on DC to AC. Please remember me. The first one, general purpose diode. Maybe the voltage rating will be 50 volt to 5 kilovolt. KV indicates what? 5 kilovolt. And the current rating might be less than 1 ampere to several thousands of ampere. It may be used in low power applications. So this may be your first set of diode, first set of today's PPT. So post all those things in your GCR. So here, whatever the discussed on the first set of PPT, which comes under the category on power semiconductor device or semiconductor device, power converter types. Okay, power electronics and drives, and these are the things we discussed about power electronics. Then power electronics, why it is required, advantage, disadvantage, then power electronic system and the semiconductor. Semiconductor device in the sense I told you many solid state switches, all those things are constituted together. We call it as a semiconductor device, or you may be learned about semiconductor physics. Your silicon, germanium, these are the materials you might be used with, and it may be act as a substrate. So therefore, semiconductor physics plays a vital role into the existence on the manufacturing on this type of products. I'll just stop sharing this one. And I'll close this side and open another one. Please be online and just open the another slide. next one I'll try to open. Okay. See, whatever I'm trying to show here. Okay, I think it's this one. So these all things also, see, today's class, whatever we discussed, everything are most known by you. These are all the things. Again, we have a pressure. Already you learned about it. So, what is the other name for? Already we discussed about diode. So you know what is happening in forward bias, reverse bias, and also the characteristic curves. In the diode, we may consider about the reverse recovery time at the rate of 25% or 1/4 to the value. Please remember. And second case, we are trying to deal about thyristors. So you all know about thyristor, the other name you might be called the silicon control rectifier. The three terminal, you will have four layers. So PN, anode, cathode, gate. Then the name thyristor is derived from a combination, sorry, called the thyratron. The other commercial name, thyratron. From that only they have got and the translator, transistor, they have used the word thyristor. So please remember, two things are combination. One is thyristor is derived from the combination of thyratron and transistor. So from that they have taken the notation for thyristor, or we can call it as SCR. But in the 80s and 70s, they may called this one as a waltz. Please remember valves or vacuum tubes. So when the vacuum tubes came into existence, that time these thyristors in the 80s and 70s, 75s, they may call this device as a valve. If you refer the old textbooks, they may mention this term as not a thyristor or a SCR. Instead, they may be mentioned about valves. Please remember me, okay. So this may be the diagrammatic representation of a SCR or thyristor PN junction. That means how many junctions you will have? Three junctions, J1, J2, and J3. How many terminals you will have? Four terminals, PN, anode, gate, and cathode. The thyristors typically ratings available 1.5 kiloampere, then 10 kilovolt or 15 megawatt. See the thyristor rating, because thyristor might be used for more amount of application. The typical rating will be 1.5 kiloampere, please remember. 10 kilovolt, not volt. Then 50 megawatt power handling capacity. Normally in a house power grid, you may get 40, even certain power plants, you may able to get 40 megawatt or something. At least for a thyristor unit, you are trying to acquire the amount of power withstanding capacity 115 megawatt. Please remember the mind. But how much quantum of gate current we are trying to give? Only 1 ampere. That means you just imagine we are just giving a flickering of a signal for an instant triggering, for an instant moment. That's all. That's all. Just imagine remaining values and this value, what quantum of deviations you will have. Whenever you wanted to give a triggering amount of pulses on the gate, you wanted to have a very less amount of value, that is 1 ampere. So this may be the basic structure of your SCR. The SCR structure looks like this, PN. So here you will have anode, cathode, and the gate. This is the physical structure or the interlinked structure or the physical property of the appearance of your SCR. So this maybe we should remember at least equivalent circuit diagram. So either I may have a PNP or I may have a NPN with three junctions, J1, J2, J3, or I can draw it in the other form, either PNP BJT or NPN BJT. So both the gate terminals are connected here. So in both the base terminals are comes into the picture, and we are trying to give to a common gate. But my point. Okay, so SCR, the moment you try to remember about that diode, you should remember about reverse recovery time. At the same time, SCR, you all know about latching current, holding current, all those things. So, latching current, holding current, and forward blocking and reverse blocking. Please remember. So, latching current, the minimum value of anode current, which may attain to turn on the process to main the conduction when the gate signal is removed. Though you may remove the gate signal, but the minimum value of anode current which is required to attain during the turn on process to maintain the conduction. Holding current, the minimum value of anode current. The earlier one, latching current, will maintain till the end of the conduction, but at the same time holding current of anode current below, which is first fall for the to turn off the thyristor. Holding current is a minimum value of the anode current, which is must fall for turning off your thyristor. The earlier one to turn on, and here you will have turn off. And this is the VI characteristics of SCR. I think you have learned this one. So the VI characteristics, there are four things. One is forward conduction, and another one is forward blocking. Second one, reverse conduction, and reverse blocking. So forward conduction, forward leakage current. Then again forward blocking. Then reverse conduction, reverse leakage current, and reverse blocking. These are all the terms during the voltage and current characteristics of an SCR when you connect across the load. Here the diagram shows about a symbolic representation of a load. I may have the SCR, my gate terminal is now open. So suppose with the moment I start giving the supply through the source or my source E. So please remember in your mind, here across the source I have a resistor symbol. So that means here my voltage is trying to divide. My voltage is trying to divide. So therefore, during this, when the switch is at closed position, yes position, automatically what will happen? The variable amount of supply will be trying to trigger to the gate terminal, thereby your SCR will turn on, thereby your forward conduction starts place. So sixth set of things, please you should remember about that. One is forward conduction, then forward leakage current, again forward blocking, then reverse leakage current, reverse blocking, and reverse conduction current. So these are the things you should remember about the VI characteristics of ACR. Same VI, please remember in your mind, if you take the diode, or if you take the SCR, if you take the triode, or if you take the diode AC switch, or triode AC switch, then the other switching devices, if you take, every characteristic curves are similar, provided depends on the gate terminal. See here, we have a condition Ig3 is greater than Ig2, which is greater than Ig1. That means Ig1 you are trying to consider it as a very minimal amount. Ig is nothing but the gate current value. So this may be the static characteristics of the voltage and current relationship for any set of switches. Almost every switch's characteristics, the curve symbol looks like a similar symbol, provided the value may be varied. There we spoke about the reverse recovery time. Here we are speaking about two things: latching current and holding current. Okay, and these are all the SAR operating modes, as I told you earlier. Forward blocking mode, then anode is positive with respect to cathode. Second one is forward conduction mode. Anode voltage becomes greater than your voltage which occurs across your thyristor. Then reverse blockage mode, when the cathode is more positive than your anode, just vice versa. Forward blocking mode, anode is positive with respect to cathode. Then similarly, what will happen? Reverse blocking mode, cathode is more positive than your anode. And the thyristor operation principles, again the same stories gets repeated. Thyristor has three junction. I don't want to repeat J1, J2, J3 anode. So there are the VAK indicates what forward blocking state on the nothing but the forward voltage which happens across your cathode side. So 6 states you should remember about that: forward blocking, forward conduction, reverse blocking, reverse conduction, then latching current and holding current. Then triggering methods of ACR. Why we go for triggering methods of ACR? Why I wanted to give a triggering? So thyristor is a turning on, which is called it as a triggering. So whenever we are trying to turn on a thyristor, then I may call it as a triggering pattern. So thyristor is turning on is also called as triggering. Please remember in your mind, whenever you are trying to where you are trying to turn on. Thyristor is turning on is called not called triggering. We are trying. Where you are trying to exactly turn on the gate terminal. Please remember. Second one, with the anode positive with respect to cathode, the thyristor can be turned on by the following technique. What are all the techniques? Forward voltage, gate triggering, dV by dt, temperature triggering, and light triggering. Forward voltage, okay, you all know that gate triggering in the particular instant of on the gate side. dV by dt due to voltage stress. Then temperature triggering due to the high amount of temperature. What exactly we are trying to speak about light triggering? Light triggering You are trying to pass the light rays on the particular gate terminal. Thereby, you are trying to trigger the ACR terminal and make the device to be functional. Please remember. These are all application aspects. So forward voltage triggering. Similarly for dV by dt. dV by forward voltage triggering, we are trying to maintain the electrical current at the breakover voltage, and also when the breakover voltage exceeds the thyristor value or the maximum voltage of the device, then thyristor will be in on. That means, however you are trying to turn on your device, will try to give the breakover voltage when your di by dt value is lower. The rate of change of current value, the di by dt value will be must be lower. That you are trying to speak about for forward voltage triggering. Similarly for dV by dt triggering. So earlier one di by dt triggering or forward voltage triggering, and please remember this one. Here we are trying to speak about the second triggering is dV by dt. dV by dt itself is it will give you the clear word. V indicates about your voltage. That means you are trying to speak about the capacitor value. That's why IC equal to the charging capacitance between your anode to cathode, or IC equal to C into dV by dt, or you are trying to fetch the junction capacitance value due to the large junction area which may happen and which may behaves like a free charge area which is present on the particular triggering type. So second one is very important. dV by dt triggering is much useful when you go for the IC value, or the IC indicates what? IC indicates capacitor current, or IC equal to charging current. We may call it as D equal to dV by dt. And third one, temperature triggering. Temperature triggering voltage across the junction, maybe due to the junction area where the temperature may rise. How many junctions we heard? 3 junctions, J1, J2 and J3. Which are the junctions you may have? Where the junctions will able to raise the amount of temperature, then due to the increase in temperature, leakage current will flow through that particular junction, thereby it may get increases, or a thermal quantum of effect may be happened. Therefore, that is called it as thermal runaway, or generally thermal, we may call it as temperature triggering. And light triggering. This is little important. So light particles, as I told you earlier, by passing some light or light kind of things. Light particles are photons, right? Photons are made to strike to the reverse bias junction, which causes increase the number of electron hole pair, and thereby you are trying to trigger the things. That means here you are trying, you have a PNPN, you are trying to pass the light out to on the reverse bias junction, provided you are trying to increase the number of electrons on hole pairs and to trigger the thyristor. So PN. So another one may be while passing the light, you may consider another thing. So the light intensity we have to consider. Sometimes while passing the light, continuous light or quantum of pulse amount of light. Maybe when you pass the amount of light or the photons, we also should see about two things. One is the light intensity. Another one is the light wavelength we have to consider about that. That's why this type of light triggerings are much useful when you go for the HVDC transmission. What is HVDC transmission? High voltage direct current transmission. Today's people are everywhere speaking about all power grid and smart grid. People are speaking about that, right? And also one more important thing, this is called as LAS SCR. That means light activated silicon control rectifier, where thereby your silicon SCR is trying to turn on with the help of passing the light particles towards the reverse side. Or please remember in your mind, for light triggered ACRs, here we are considering, or we are trying to pass the light particles, or otherwise it is in the form of photons. And the thyristor gate control methods, an easy method to switch on and switch off. Then thyristor turn on should be in the range of 1 to 4 microseconds. See, remember, so see the timing, how much a quantum, very minimal time, 1 to 4 microseconds only. And while turn off between 8 to 50 microseconds. Thyristor gate signal can be considered three varieties: DC gate signal, AC gate signal, and pulses. Pulses earlier we discussed various amount of pulses. Pulse width modulation, asymmetrical pulse width modulation, and synchronous pulse width modulation. DC gate signal, AC gate signal. Okay, depends on the parameters. Then thyristor gate control methods, DC gate signal, application of DC gate signal flows to the gate current. Then AC gate signal, shifted amount of AC to the gate signal where you are trying to control with the help of a firing angle or a phase angle control. Then third one is pulse. So here by the application of sequence of pulses with the correct range of magnitude value. That's why. So sometimes while giving pulse, you may use some transformers, pulse transformers or isolation transformers might be used in order to avoid the losses and the discontinuities. Then commutation technique. Okay. Earlier one, so far we discussed about all the pulses. Pulses we are trying to turn on the thyristor. Well, wanted to turn on the thyristor, and we are trying to give the adequate amount of pulses which is required for that. Next one is commutation techniques for ACR. Okay. I told you earlier, I hope you all remember natural commutation and forced commutation. Under natural commutation and forced commutation, what are all the other things you have? Current commutation, voltage commutation. That's why voltage fed current source inverter and current fed current source inverter. CSI and VSI. Voltage source inverter and CSI is current source inverter. So here a thyristor can be turned on by applying a positive voltage or a positive current for a few amperes at the gate cathode terminals. Please remember, commutation, not only you are trying to apply a positive voltage, at the same time you are trying to apply a few amount of sometimes for a few amount of milliseconds or current. That means you are trying to apply a voltage or current either in the form of a di by dt operation or dv by dt at the rate of voltage or milliamps at the gate cathode terminals. Here, the process of turning off a thyristor is called commutation. It can be classified as natural commutation, forced commutation, current commutation under category voltage commutation. So basic structure and operation of GTO. What is GTO? Gate turn on. GTO is nothing but GATE, gate turn on. So gate turn off a thyristor or GTO, please remember, it's another type of thyristor. SCR can be easily turned on by positive gate current. Once it is in on state, gate losses is controlled. Thereby, GTO techniques may be used, or it may be easily turned off by providing a amount of pulses, either the negative pulse or with the appropriate amount of amplitude to the particular terminal. Gate turn off thyristor basic structure. GTO is a PNPN. How many terminals? 3 terminals, which anode, cathode, and gate. SCR P plus layer and GTO then N plus layer. So gate turn off thyristor, please remember movement. It's a 4-layer, 3-terminal structure. PNPN is a 4-layer, 3-terminal structure with the anode. So PNPN, so combination. So this is the almost it is like a SCR schematic representation. So here I have a PNP transistor and NPN transistors are back to back connected. The basic operation is same as the conventional thyristor. The principal difference is the modification which may happen based on the gate turn off method. Either I should design about my triggering pulse alpha 1 at the first transistor towards my second transistor. That means alpha 1 plus alpha 2 must be larger than the value on. Next one, VA current. What is the voltage and current characteristics of a gate turn off thyristor? VA characteristics may be identical with the SCR, but here the range of voltage may be 100 to 500 milliamps, and the amperes may be like around 2 amperes. So this is the range of value for a gate turn off. Advantages. What are all the advantages you have GTO over SCR? Well, so strictly speaking, remember, now commercially people are sticking on to SCRs only, not much on GTOs. GTOs may have more amount of application, but when you wanted to go for more amount of power switching power frequencies, then we should be labeled on to SCR. Or I can go to MOSFET, metal oxide semiconductor field effect transistor. Please remember me on mind. Or the other one IGBT. But all together, I'm strictly speaking, I can say that many today's power switching applications, either if you go by solar plant or if you go by charging station, inverter, converter, most of the areas people are stick on to SCR or thyristor. Never forget about that. The gate of the turn of thyristor has more di by dt rating. Commutation is not required. High amount of efficiency. Then you can also reduce the amount of noise and electromagnetic noise due to commutation chokes. Maybe here you may have a commutation chokes. Due to that, you can be able to avoid electromagnetic noise interference. If the weight of the device may be much less, cost is much less, and in terms of these are all the advantages. You have your gate turn off thyristor over your silicon control rectifier. Next one, okay, second one, SCR. First one, basic diode we discussed. The second one, thyristor or SCR we discussed. Next one, GTO we discussed, gate turn off thyristor. Next one, the triode AC switch, TRIAC. TRI indicates what? Triode, AC indicates AC switch. Triode for alternating current, or that means we are trying to give it for the AC equipment. Therefore, it may be used in motor speed controllers, then pressure control system, light dimmers, and other AC control equipment. So please remember, this triode may be alternating current. You might be, I think, noticed in many places, like speed controllers. Wherever you wanted to control the speed control of a machine motor or machinery units, there you are trying to use about the triode switch, also AC switch. Then pressure control system. I think wherever you are trying to speak about the pressure valve control, pressure mechanisms control, in order to deviate the amount of pressure from the from one stage to another, water flow pressure or any industrial fluid flow pressure control systems. There you are trying to use triode. Light dimmers, you all know about light dimmers, the flickering of light or changing the color of light from one to another, or light dim, the brightness and dull, dim. That light dimmers may be used by the triode switch, or these are all the AC control equipment switch with the help of a triode. Like almost like decorating items, these all the places they may be used this triode for alternating currents and other things, for decorative items and other purposes. Next one is a triac. Sorry, triode AC switch. Sorry, continuation. Triac is an important member of the thyristor family. Triac is a bidirectional device, and triac is equivalent to back-to-back SCRs. That means two back-to-back SCRs are connected with one gate terminal. Already we discussed about SCR. How many terminals, gate terminal you have? Only one terminal. But here, two set of SCRs are back-to-back connected, provided only one gate terminal. Please remember that. Don't forget triode AC switch. Don't consider think that when two SCRs are back-to-back connected, two gate terminals. No, only one is a gate terminals might be considered for see the diagram. Now you will come to know how they are back to back connected your SCR. Normally SCR, I have the terminal two terminals along with the gate, but here I have the terminal MT1, MT2 and gate terminal. Or this is how the diagrammatic representation for a triac. Circuit symbol or a two thyristor analogy method. And here in both the condition, when MT1 is forward bias with respect to MT, then no current flows from MT1 to MT2. Similarly, when MT2 is in forward bias condition with respect to MT1, then no there is the current flows from MT to MT1. So when MT1 is in forward bias condition with respect to MT2, what will happen? Current flows from MT1 to MT2. Similarly, when MT2 is forward bias with respect to MT1, then what will happen? Current flows from MT2 to MT1. This is how the stage of power flow which might be happened on your MT is indicates main terminal. Okay, don't forget, don't confuse that. Main terminal 1 and main terminal 2. G indicates what? Gate terminal. Please don't confuse that. Don't immediately. Usually we call it as a terminals, right? But here, in order to have a deviation, so main terminal 1, main terminal 2 in triac. So this may be the construction. Triac may be a 5-layer, 3-MLA terminal semiconductor device marked by MT1, MT2, main terminal 1 and 2 with the anode and cathode terminals of case of SCR. So this may be the physical properties with the diagrammatic representation on a triac diagram. Okay. Working and operation of the triac. Okay, as we discussed earlier, when MT1 2 is positive with respect to MT1, then second case, 4 set of categories we will have here. 4 set of operation we will have. One is MT2 2 is positive with respect to MT1. Second one, MT2 is positive with respect to MT1 with the negative polarity. One is first one with the positive polarity, negative polarity. Second one with the negative polarity. And third one, MT2 is make a negative with respect to MT1. And fourth one also, MT2 is made negative with respect to MT1 with the positive aspect. Okay, gate polarity might be positive. So first two cases, your gate polarity with a gate polarity positive with respect to MT1, and the third and fourth case you have a gate polarity negative with respect to MT1. So four set of operations you will have: MT2 positive with respect to M1, MT2 positive with respect to MT1, and finally MT2 is negative with respect to MT1. So all the four cases, first two cases you have a gate polarity positive with respect to MT1. Second one, a gate polarity positive with respect to MT1. So for MT1 2 indicates main terminal 2, and the MT1 is the main terminal 1, and G is the gate terminal. Then track. So here most of the applications are negative triggering current circuit is used. 2 to 3 quadrants are used for label triggering. 2 to 3 quadrants in the sense they are trying to speak about the quadrant of operation. First quadrant, second quadrant, third and fourth quadrant. That means it's trying to occupy the 2 to maximum 3 quadrants by a triggering amount of bidirectional current, not a unidirectional current, bidirectional current when the gate sensitivity is much critical. Please remember me. So these are all the diagrammatic representation. When I told you about how many operations: mode 2, mode 1, mode 2, mode 3, and mode 4. When first case you will have, if your MP2 terminal is positive, which is considered positive gate current. Second one, MP2 is positive, but with what current? Gate current is made to be negative. Similarly, third case, MP2 is negative with the positive gate, then MP2 is negative with negative gate current. Okay. This diagram may be the VI characteristics of a triac. So this diagram, this characteristics curve may be show about the voltage and current characteristics of a triac. So here also your Ig1 value is much greater than Ig3 is greater than Ig2, which is greater than Ig1. That means your breakover voltage VBO is at some extent it may consider here in the first quadrant, that value may be considered here as 0. So your breakover voltage in the forward direction and your reverse directions are much larger when we considered about the previous triggering on the track in both the direction. The earlier cases are the breakover voltages are much much lower, but here it's very much lower than the previous case. Therefore, the rating of the track is considerably lower than the thyristors. Advantage and disadvantage of triac. Triac may be used by positive and negative polarity. That's why MT2 is on MT2, again MT1. 4 set of terminals we considered for 4 set of operations. MT2 and MT1 considered to be positive and negative polarity. But my point, that means we are trying to trigger both the positive and negative polarity. Then DC applications, SARs are required to be in parallel, diode to be protect against reverse voltage. That means, please remember in your mind, many DC applications, SCRs may be connected with the parallel to the diode in order to protect the device with the reverse voltage. Please remember in your mind. And disadvantage, maybe it is less reliable and it is a very small switching frequency, and also it may be available in the lower power rating. As I told you earlier when we begin this subject, we are not going to use all these switches. Many switching fundamentals we should know about that, but out of all the fundamental, suitable amount of reliable power switches only will be considered when you go for your switching device or when you go for your driving unit. That means I told you, I suggested many times, we go by what I say, this one, SCR or thyristor. Application of triac may be acting as a switch. Triac may be act as a switch because both the direction, bidirectional unit AC, used in AC power controllers, fan controllers, already we discussed, heat controller, triggering devices. So these are all the areas where we are trying to apply your triac. So fan control, heating control, then triggering control, and position control. These are all the power control areas where we are trying to use by triggering both the positive and the negative aspect. Then phase control. Phase control, we are trying to control the phase voltage of a particular. Normally, if we have a sinusoidal voltage, so which angle you wanted to have a phase control, where you are trying to trigger. Accordingly, you have your own amplitude at the positive half cycle and at the negative half cycle. Please remember. Triac versus ACR. So when I compare these two things, triac triode AC switch, and the SCR. Maybe triac is a bidirectional device, SCR is a unidirectional unit. Triac, how many terminals? 4 terminals. Sorry, 2 terminals, MT1 and MT2 with the gate. But SCR has what? Anode, cathode, and gate terminal. Then here both positive and negative gate current, but the triac conducts with only direction on gate current turn on to the SCR. So here positive and negative gate currents on triac conducts, but there we have gate current either to be turn on or at the turn off. Reliability is much less which compared to the SCR. Triac characteristics are much available on less rating only rather than SCR. That means from the conclusion what we are trying to say about that. We are trying to say about that we will try to prefer about SCR. Though triac may have a lot of advantage, but when you speak it in the aspect on application point of view, we have to look into for SCR only or thyristor based. So with this PPT, I'll try to wind up. Okay, this 2 set of PPTs I'll post it here. Okay, at the end of the hour, please be online and just take the attendance. And guys, I think 2 hours continuous dry theory. I don't know how many of you slept, and I don't know how many of you have taken lunch. I do not know, but anyhow, there is no way because the time is like that. I cannot do anything because time 12:30 to 2:15 is a hectic time for sleeping. I think many of you slept, or I don't know whether you are listening. God knows. Anyhow, number 26, Mohit Jain.
Present, sir.
Good. Number 27, Saravanan. I think Saravanan is sleeping. Saravanan. Number 28, Nikesh. 29, Dhananjay Chauhan. 29. Number 30, Sri Shitaria. 30, Sri Shitaria. 31, Sangeet Sanjay Patel.
Present, sir.
32, Sri Darshan.
Present, sir.
33, Vishnu Roop.
Present, sir.
34, Tarun.
Present, sir.
35, Jaydeep Singh.
Present, sir.
36, Anshul Mehta. 36. 37, Mugilan.
37%, sir.
38,
38%, sir.
39, Nitish Reddy.
39 present, sir.
40, Manish Selvan.
40 present, sir.
41, Mohammed Zayed.
41 present, sir.
42, Atiswaran.
Present, sir.
43,
Present, sir.
Sudarshan Banerjee.
Sir. Hello.
44, Jeshwant.
Present, sir.
45, Suraj Menon.
Present, sir.
46, Ritesh Babu Alam.
Present, sir.
47, Mark Henry D'Souza.
Present, sir.
48, Sivaguru. 49, Sylvester Francis.
Present, sir.
50, Bharatwaj.
Present, sir.
51, Jubil Kurian Biju.
Present, sir.
52, Harikrishnan.
Present, sir.
53, Harshita.
Present,
54,
sir.
Present, sir.
I don't know. What is your name? I don't know.
Bhanode, sir.
Banode. Okay, fine. Sorry. 54 present. 55, Muhammad Naim.
Present, sir.
57, Subin Babu.
Present, sir.
58, Aram B. Shah. 58, Aram B. Shah. 59, Bogendra Vishwasha. Sarigonda Bogendra Abhivasha. 59, no idea. 60, Jayashankar. 60, Jayashankar. 61, Darshan Bharat.
61%, sir.
62, Venish Krishna.
Present, sir.
Venish
52.
Krishna. 63, Pawan Ganesh.
Present, sir.
64, Joel Zakaria. Joel.
Present, sir.
65, Saritesh Vimula.
Present, sir.
66, Hariharan.
Present, sir.
67, Jiva.
Present, sir.
68, Abhijit.
Present, sir.
69, Samuel.
Present, sir.
70, Hemanand.
Present, sir.
71, Praneeth.
Yes, sir.
72, Raghavendra.
Yes, sir.
73, Jagish.
Present, sir.
74, Chandan Chai. 74, Chandan Chai. 75,
Present, sir.
Ayushman Bhatia.
Yes, sir.
76, Kola Sanmukh Sai.
Present, sir.
77, Alok Ranjan Panda. 77, I read the absentee's name. Please, if you are present, just respond me.
27%, sir.
27. Then 29, Dhananjay. 30, Sri Shitaria. 36, Anshul Mehta.
He's
36.
present only, sir.
Pardon? I don't get.
So 36 wrote in the chat box.
Okay,
36.
thank you. Yeah,
He's present only, sir. Written in chat box, sir.
yeah. Anybody else is written in the chat box?
Sir, 48, sir. 48 has written in chat box, sir.
Okay, fine, thank you. Then 58, Param Bisha.
58.
So he also wrote in chat
58.
box.
Present, sir.
Okay. 59, Apish Varsha. 59, 60, Jay Shankar. Then 74, Chandan Shai. 77, Alok Ranjan Panda. So these are the absentees. Okay, anyhow, I will post the attendance immediately. You just check it in your Zoho. Okay, I'll post. Yeah, I'll post all the materials in your Zoho. Okay, GCR. If you're not connected, please connect yourself. The next
Okay,
class
sir.
you'll see that.
Post the videos also, sir. These are recorded videos.
Recorded videos. I have not
Yes,
recorded
sir.
any video.
Sir, the meeting is currently recorded, sir.
Automatically recorded.
Yes, someone has started the recording. So whoever has started recording, please share the video.
Okay. Okay. Thank you. You can leave. Thank you.